Okay, moving on to question 16. It says the equation x squared plus y squared minus 2x plus 6y plus 3 equals 0 is equivalent to. Well, one thing you could do with these is cheat a bit and just multiply out, use FOIL, and sort of simplify each of these four equations to see which one turns into this x squared plus y squared minus 2x minus 6y. That's actually it's actually plus 6y plus 3 equals 0. But I'm going to teach you the official way to do it. You don't have to do it this way, but this is sort of what they're getting at in this question. If you rearrange the terms so that the x squared and the 2x or negative 2x are together, and the y squared and the plus 6y are together, and you move that plus 3 over to the other side, you can get this thing to look like these answer choices by doing something called completing the square. Completing the square is based on the fact that if you take something like x plus 3 and you square it, what always ends up happening is that this last term always ends up being half of the middle term squared. And it works the other way around also. If you ever notice something where the last term is equal to the square of half the x term, then it will be a perfect square trinomial and can be factored, in this case, into x plus 3 squared is x, and then half of this coefficient squared. So x squared minus 2x is not a perfect square trinomial, but if you divide minus 2 by 2 to get minus 1 and then square it, you get plus 1. If you put the plus 1 here and here, and on this side, cut the 6 in half and square it to get 9, you add that to this side and to this side. This thing is now a perfect square trinomial, so it can be turned into x minus 1 squared. This is also a perfect square trinomial. It can be written as y plus 3 squared. And this becomes 7, which is answer choice 2. But you can do it the shortcut way or the less complicated way by just multiplying out all the 4 choices until you find the one that equals what the question says. Okay, moving on to question 17. Which graph best represents the inequality y plus 6 is greater than or equal to x squared minus x? So an inequality is you use shading to make an inequality. Like for instance, y equals x is just a line, but y is greater than x. These are all the points where the x and y value are equal, like 1, 1, 2, 2, 3, 3, 4, 4. Y is greater than x doesn't have 1, 1 as a point on it, but it does have 1, 2, and 1, 3, and 1, 4, and 1, 5. Those are all points where the y value is greater than the x value. And when you do that for all the points, you get something that looks like shading. So we have y minus 6 is greater than or equal to x squared minus x. And y plus 6 is greater than or equal to x squared minus x. Well, this parabola cuts the plane into sort of a region inside the parabola and outside the parabola. Let me see, what's the difference between these? Oh, I see. So x squared minus x, that we need to graph that parabola. Easiest way to graph x squared minus x is x times x minus 1, which means that if you set that equal to 0, you have your intercepts at 0 and regular 1. Oh, never mind, I have a better idea for this one. I'm doing this all in one take, so I am not rewinding and pretending that I didn't start on a false dead end on this one. Good lesson for everyone to learn. If you add 6 to both sides, x squared minus x, this actually says plus 6 in the original, so minus 6. So we graph this parabola. X squared minus x minus 6 can be factored to x minus 3, x plus 2, So x equals 3 and x equals 2, negative 2 are the two x-intercepts. And that is why we want choices A and B, or 1 and 2 are the only, 1 and 3, sorry, are left. These are out because those are the wrong parabola. Now, for y is greater than, it's going to be shaded sort of above the parabola. See, these are the points where y equals x squared minus x minus 6, which makes any points above them the places where y is greater than it. That's why your answer, that's why your answer here is choice 1 and not choice 3. You could actually take a point like 0, 0 and plug it in for x and y, and you get 0 is greater than or equal to negative 6, which is true. That would tell us that we want to shade the portion of the parabola that does have 0, 0 in it. That's actually a pretty hard question there. Moving on to question number 18. The solution set of the equation that says x plus 3, square root of x plus 3 equals 3 minus x is. A traditional way of doing this question is to square both sides. When you square square root of x plus 3, you just get x plus 3. When you square 3 minus x, you do not get 9 minus x squared, but you get something you have to use FOIL for. And notice how after we move everything over to one side, we end up with a quadratic equation, which can be solved in this case. X minus 6, x minus 1. So we get two answers, x equals 6, x equals 1. You got to check your answers to make sure that when you square both sides, you run the risk of introducing something called extraneous solutions. If you put 1 in, you get square root of 1 plus 3, which is square root of 4, which is 2, and 3 minus 1 is 2 also. But when you put 6 in, you get square root of 6 plus 3, which is square root of 9, which is 3. But 3 does not equal 3 minus 6, and that's why if you wrote this, you would lose full credit because the answer is just 1. So check for extraneous solutions on a question like that. Number 19. The product of, I think that says I to the 7th and I to the 5th. Let's see. Yes, it does. Well, I to the 7th times I to the 5th is I to the 12th. Powers of I to the 0 is 1, anything to the 0 is 1. I to the 1, I to the 0 is 1, I to the 1 is I. That's just anything to the first power. I squared is negative 1. That's the definition of I. And I cubed is negative I. Then it actually continues. I to the 4th is back to 0. So you could just go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to get your answers 1. Or a little trick for you is to divide, to raise I to a power bigger than 3. Divide the power by 4 and raise I to whatever the remainder is to get that answer. Number 20, which equation is represented by the graph below? So this is pretty tricky. Here are your 4 choices. You could type these all into your graphing calculator. Just remember, graphing calculator has a tan button, but it doesn't have secant, cosecant, and cotan. But you could graph them by doing 1 over cosine x, or 1 over tan x, or 1 over sine x. Remember, a sine curve looks like this, and a cosine curve looks like that. That's why this answer is secant x, because when you take the reciprocal of all the y-coordinates of a cosine curve, this starting point at 0, 1 still is 0, 1. But as cosine gets closer to 0, and you take the reciprocal, you get higher numbers. See, this negative 1 here corresponds to the negative 1 there. So this is the graph of y equals secant x. 21. Which value of r represents data with a strong negative linear correlation between two variables? So if you have a scatter plot and it looks kind of like this, there's a line of best fit that goes through it, and r, the closer it is to 1, the more it's like a line. So this might be 0.9, Whereas if they actually were on a line, r would be exactly 1. R can't be bigger than 1. If the dots are like this, r might be negative 0.9. And if they're exactly making a downward sloping line, it could be negative 1. So the answer to this is question 2. It's got to be negative because it's got the negative coefficient. This actually has a negative in front of it, but you can't have 1 is the biggest it could possibly be. 22. The function f of x equals tan x is defined in such a way that f inverse x is a function. I'm real surprised about this question. So the graph of tangent looks something like this. You can do it on your calculator even. For the inverse to be a function, vertical line test means it's a function, but something called a horizontal line test tells you when the inverse is a function. So we want to just keep the portion of this graph so that no horizontal line goes through 2 points on the graph. In other words, we're just going to keep this portion over here. So it's negative 90 to negative 90 to 90, but in radians it's negative pi over 2 to pi over 2. That's a pretty hard question. If you're happy to get like a 90 on this Regents or 95 and not 100, that one would not be that important to study. 23. Incidentally, I am capable of really good explanations of some of these, but I'm assuming that you're cramming for this test, that it's tomorrow or something, so I don't want to bombard you with too much math theory. You can go to my other YouTube tutorials to get more of that after the test. In the diagram below, we got a side of 6 and a side of 5. They want to know what is the measure of angle K. Well, we use SOHCAHTOA for this. In relation to this angle, the 6 is the hypotenuse and the 5 is the adjacent, so we can use cosine. So cosine K equals adjacent over hypotenuse. And to get the answer for K, we do cosine inverse of 5 over 6. So we take our graphing calculator and do second cosine, that's cosine inverse of 5 over 6. And we get our answer, 33.5573 degrees. 33.557 degrees. Well, all the choices, they want the answer in the nearest minute. So the idea is there's 60 minutes in a degree. So if you take this 0.557 and multiply it by 60, you'll get your answer. So I'll do it this way. I'll just subtract 33 and then multiply the answer by 60. And I get the number of minutes, 33.43 minutes, or 33. Answer is choice 1. Question 24. Cosine squared theta minus cosine 2 theta. Well, there's some trig identities that are actually given to you in the back of the Regents book. For cosine 2 theta, there are 3 versions of it given to you on the back. One of them is 2 cosine squared theta minus 1. So if we do cosine squared theta minus parentheses, we would get negative cosine squared theta plus 1, which is choice number 4. So that's one of the formulas given to you on the reference sheet. Question 25. Mrs. Hill. She asked her students to express the sum 1 plus 3 plus 5 plus 7 plus 9 all the way up to 39 using sigma notation. I'll do this one in the next part, so to be continued. Okay, let's take a look at this one. What sigma notation means. If you see a sigma and you see something like 2k, k equals 1 to 5, that basically means set k equal to 1, plug it in, you get 2 times 1 is 2. Plus, always plus, that's what the sigma means. Then you make k 1 bigger, make it 2, plug it into the formula here, becomes 4, then plug 3 in, then plug 4 in, then plug 5 in, and add them all together. That's what sigma notation means. So if it was 2k, it would make all the even numbers. If I go 2k plus 1, k equals 1, starts at 1, I would get 2 times 2, or 2 times 1 is 1, plus 1 is 2 times 1 is 2, plus 1 is 3. Maybe I better do 2k minus 1. That would get me 1 as my first number. And I want to go up until I hit the number 39. Well, 39 would come out if 2k was 40, so if k was 20. So this would make 1 plus 3 plus 5 all the way up to 39, which is why the answer to this question is choice 4. Now, going backwards is a lot harder, like taking something like this and turning it into a formula like this is a lot harder than going forwards. That's why you could also have done this question by testing the answer choices. For instance, if you wanted to check answer choice number 2, you'd plug 2 in to this formula, 2 minus 1 is 1. Then you plug 3 in for k, and you get 3 minus 1 is 2. You'd see that this is wrong. It's not 1 plus 3 plus 5. So you get a lot of time for this Regents, so you can, especially in the multiple choice, test your answer choices that way. Now there's other questions that won't have choices, so it's good to know how to do it the regular way also. 26. What's the formula for the nth term of this sequence? 54, 18, 6. So this is, notice how each term is 1/3 of the term before. This is called a geometric series. 54 times a third is 18. 18 or divided by 3 is 6, and the pattern would continue that way. The first number is 54, that's A1. A2 is 54 times a third. A3 is 54 times a third squared. In general, AN is 54 times a third. Notice when it was a 3 here, it was 1/3 squared that we multiplied it by, so it's n minus 1. This is also a formula that you can memorize. I'll write it up in a second. This copy didn't come out good. Here's the answer. That's an equals. In general, the formula for a geometric series is AN equals A1 times R to the n minus 1, where R is the common ratio. For completeness, if it's just arithmetic, it's AN equals A1 plus D times n minus 1. That's the answer for number 26. And number 27, they want to know what's the period of the function y equals 1/2 sine x over 3 minus pi. Pretty hard question. I personally like to factor out this 1/3. And I basically divided this and this by 1/3. That's where this 3 pi came from. This thing won't, if you don't know where the 3 pi came from, it's not important anyway, because for a period, it's based on this. And the formula is that period is 360 over this coefficient. Or if it's in radians, it's 2 pi over that, which becomes 6 pi, which is the answer for this question. This means if we graph this thing, it would be real wide. It would be really wide sine curve because the period got bigger. Well, that takes care of part 1. As you can see, this is not a very easy test. It's pretty grueling, actually. I'm getting pretty tired. I'm trying to do this all in one shot. and talk about all the answers. 28. Here we're into the part 2s. Very careful on part 2. They're only worth 2 points each, and if you make the slightest error, you lose 1 point of those 2. So dangerous here. Be very careful. The discriminant is what you get when you do b squared minus 4ac if you have a quadratic equation. If the discriminant is greater than 0, there's 2 real roots. If it's equal 0, there's two real, these are unequal. So if it's equal 0, it's 2 real equal roots. And if t is negative, it's no real roots, 2 imaginary roots. So when they say we want to have real roots, we're trying to get b squared minus 4ac equals 0. Well, this is b is negative k, so it's negative k squared minus 4, a is 1, times 4 equals 0. Negative k squared turns into regular k squared, minus 16 equals 0, k squared equals 16, k equals plus or minus 4 is the answer to that. That will get you 2 points. Question 29. So here we have a situation where we have these different test scores, and these different numbers of people have gotten these scores. And they want to know something called the population. Pay no attention to that. They want to know something called the population standard deviation. Now, if this was a 6-point question, I'd show you the long way of doing this by hand, but it's just a 2-point question, so I think they're expecting you to just use the calculator, so I will teach you how to use the calculator for this question. Let me just make this a little smaller. There we go. Okay, so you clear out your calculator, and we're going to input into these lists. Hold on a second. That is not what I wanted to do. Instead, I think what we want to do is push stat and edit. Now I could put into these 2 lists. I could literally just type this all in. Type 96 for we're inputting those scores into list 1. 92, 84, 80, 76, 72, 68. Those are the regular numbers. Now, if I move over here to list number 2, I can put in the frequencies. 1, 2, 5, 3, 6, 3, 2. So you have 2 different things here. You have list 1 with the test scores, list 2 with the frequency. If you go to stat, calc, and then you go down to not to 2 variable stats. Standard deviation is still 1 variable stats. But you have to be very careful here. If there was a list and also a frequency, you have to say L1 comma L2. To get L1, you go second 1. Then you put the comma, which is here above the 7. And then second L2. I don't know if this is going to work, because let's just take a look. Try that again. Second, sorry, clear, stat, calc, sorry, 1 variable stat. I'll just go this way. Second list 1, comma, second list, go to number 2, and then say enter. And the standard deviation is this one, the 7-point. This is called the population standard deviation, this little sigma sign. Don't put this one. This one you lose half credit for, the 7.53 7.38. Also, they want it to the nearest tenth. So the answer is 7.4 to get full credit for that question. 7.4. Go used calculator. Say that just in case your teachers want to know where that answer came from. Question 30. Find the sum and the product of the roots. The equation is hard to read. It's 5x squared plus 11x minus 3 equals 0. Well, you could use the quadratic formula, get the two roots, add them, and multiply them, or you could use the formulas. Sum is negative b over a, product is c over a. These are good formulas to know. Negative 11 over 5, product is negative 3 over 5, and this question is done. So knowing those two formulas would have come in handy. He says 5x squared plus 11x minus 3 equals 0. Question 31. The graph of the equation 1/2 to the x has an asymptote. Okay. Well, to do y equals 1/2 to the x, you can do it on your calculator, but we don't need to. Make a chart, x, y, negative, no, I'll go back. I'll go negative 3, negative 2, negative 1, 0, 1, 2, 3. 1/2 to the 0 is 1, 1/2 to the 1 is a half, 1/2 to the second is 1/4, 1/2 to the third is 1/8. That gets us these points. So already you can see just from that the asymptote appears to be y equals 0, this x-axis. But we want more of the graph, so it's a little tricky. 1/2 to the negative 1, you could use your calculator for it. I like to just do it regular. It becomes 1 over 1/2 to the first, which becomes 2. And this actually becomes 248, which gets us this, somewhere up here. That's what it looks like, and that's the graph. Sorry about that interruption there, but that's the answer. Both of those things you need to get full credit for this question. Equation of the horizontal asymptote, and also the thing itself. Okay, this one's a little tricky to read. It says 5 root 3x cubed minus 2 root 27x cubed. Simplest radical form. We had simplest radical form earlier on in this test. The trick is, when there's x's, to take the square root of x cubed, rewrite it as x squared times x, and then this x squared, square root of x squared is x, so it can kind of come out, they say, as an x. Now this 27 can be rewritten as 9 times 3. The 9 can come out as a 3. This x cubed can be turned into x squared times x, and the x squared could come out as an x. So we get 5x root 3x minus 6x root 3x. Those have the same sort of last part, so we can combine them. 5x minus 6x is just negative x root 3x, which I think, unless I made a mistake, is the answer to that question. Okay, that's good for now. I'll pick up on these afterwards.